Hey guys, it's Mr. Wolfe here, and I'm going to be going over the difference between mass and weight, and also how they're related. So let's first start with mass. And mass is going to be the amount of atoms, or the amount of stuff, or the amount of matter in an object. It's also important to establish some things that mass is not. And mass is not going to be volume. And when I say this, think about maybe like a pillow versus like a dumbbell you might lift. And so the pillow is going to take up more volume than the dumbbell, but the dumbbell is going to have more mass. It's going to have more matter and atoms within it. So mass is not volume, and it's also not weight, although the two are related, and we'll get to that. All right, so we're going to measure mass in kilograms. And we can abbreviate kilograms as kg. Okay, so what is weight? Well, let's say we have a mass, and that mass is going to be a person on a planet. Well, that planet's going to pull down on them. And the force that that planet pulls down on that mass is going to be the weight. It's going to just be the force of gravity on an object. And since weight is a force, our unit is going to be newtons, just like all other forces. So we're going to fill in this area right here, but before we go there, I want to go to this box further down on your page. And so what this box is going to give us is an equation that shows us the relationship between mass and weight. So it's going to be the force of gravity, and remember, the force of gravity is just our weight. It's going to be equal to mass, but remember they're not the same thing. And so it's going to be mass times a value we're going to call acceleration due to gravity. And we're going to get more into acceleration in the next unit. But for now, think of acceleration as the amount at which these planets are pulling down on our mass. And so our weight is determined by the acceleration due to gravity, a little g. And this acceleration due to gravity is going to be different on the location, or depending on what planet you're on. So we're going to say that it changes depending on location. And so let's delve into what this means. Changes depending on location. And this is going to help us differentiate between mass and weight. All right, so let's say we have a mass or a person, and we put that same person on the moon, on Earth, and on Jupiter. Okay, and let's label these planets. So Jupiter, Moon, and Earth. All right, so this is the same exact person on Earth, the Moon, and Jupiter, and so the same amount of atoms are going to be in his body no matter what location he's at. So his mass, the amount of stuff in his body, isn't going to change. So we could say same mass on all planets. And I know the Moon's not a planet, but just for simplicity's sake, we're going to say same mass on all planets. And we're going to give this person a mass of 75 kilograms, which is about the average mass of a person. The person's mass is going to be the same, but their weight, or the force, or their force of gravity on each planet is going to be different. And that's because each planet is going to have a different force of gravity. And so the larger planet you have, the greater the force of gravity is going to be. And that's why you could jump so high on the moon, as it's a smaller object, smaller mass. All right, so the acceleration due to gravity on Earth, and these are just going to be numbers to remember, are going to be the acceleration due to gravity on Earth is 9.8 meters per second squared. Now, the acceleration of gravity on the moon is going to be less because the moon is smaller than Earth, and so it's going to be 3.67 meters per second squared. And finally, since Jupiter is so big, it's going to have a very large force of gravity, and its acceleration due to gravity is going to be 26 meters per second squared. Let's calculate the weight, the actual weight that this person would weigh on planet Earth. So weight on Earth, question mark. All right. In order to calculate the weight, the force of gravity, we're going to use our equation right here in this box. And so our weight is just equal to the force of gravity, and the force of gravity is equal to our mass times the acceleration due to gravity. And so our mass is going to be 75 kilograms. That's how much stuff is in our person. And how much the Earth is pulling on this person is going to be in our acceleration due to gravity. So it's going to be 75 times 9.8 meters per second squared. And you don't always have to put the units in these parentheses. And so when we multiply these together, we're going to get that our force of gravity, or weight of this person on Earth, is going to be 735 newtons. So let's go through another example of finding our person's weight on the moon. And even before doing this problem, we could expect that this person's weight is going to be less than 735 newtons because the moon's going to be pulling on this person less. So our weight, or our force of gravity, is going to be equal to times our mass times acceleration due to gravity. The person's mass, remember, the amount of stuff in that person does not change. It's going to be 75 kilograms. And our acceleration due to gravity on the moon is 3.67. So when we multiply these numbers together, we're going to get that the person's weight on the moon is going to be 275.25 newtons. So remember, our person's mass is not going to change, but his weight, the force of gravity pushing down on him, will, depending on the acceleration due to gravity on each planet. So I'm going to give you guys a problem to work on. There might not be enough space here, so just work on it on the back of this paper. But let's say we have a different person, and we're going to put him on Jupiter. So he's going to have a different mass. And let's just say that his weight on Jupiter is 1,820 newtons. I want you guys to determine his mass on Jupiter, his mass on Earth, and his weight on Earth. All right, and that is it for our target on mass versus weight.